All right, so let's talk about seasons. Let's move me over here. I don't know where to move myself. I'll just go over here. Okay. So seasons are not caused by the distance to the sun. Okay, that's really important because in this picture we can see that here's the sun in the middle and the earth is revolving, right? Revolution revolving around the sun. And it's not a perfect circular orbit. That orbit is kind of squashed a little bit, so it's more like kind of like oval like this, not circular like that. And so there's a point in time where like the distance, this is 94.5 million miles, and this over here is 91.4 million miles. It might not seem that much of a difference, but it is a little bit of a difference. And actually, the distance when the Earth is the farthest away from the sun is actually in the mid July, July 5th. And then the January 4th is when the Earth is the closest to the sun. So that just shows us that seasons are not caused by the distance to the sun. Okay. So you can see, find on your doodle notes and write that down. Seasons are not caused by the distance to the sun. The Earth is actually closest to the sun in July. Believe it or not, July. All right. Okay, so let's think about this for a second here. Let's think about it. The seasons are caused by unequal heating of the Earth. The sun does not point at the same angle everywhere on the Earth. Sometimes it's a more direct light, sometimes it's a more indirect light. And so this Earth is being heated unequally around by the sun. And the unequal heating of the Earth is caused by the tilt of the Earth and because the Earth revolves around the sun. Okay, I'm going to say that again. The unequal heating of the Earth is caused by the tilt of the Earth and because the Earth revolves around the sun. Now, revolve, remember what revolve means? It means you have the sun in the middle and the Earth is revolving. Do it right now. So you remember revolving around the sun and the Earth is tilted, okay? Well, more like tilted like that, not like. But okay, but let's think about this. What would happen if there were no tilt and no revolutions? Okay, if there was no tilt and no revolutions, which means that if the Earth was not tilted and the Earth wasn't like going around the Earth, it was just staying in one spot and maybe spinning. Okay, then the direction of the sun hitting the Earth would never change throughout the year. Okay, because it's not actually moving around the sun. Okay, what would happen if there was tilt but no revolutions? Okay, well, if the Earth was tilted and the sun is shining on it, but it's not moving around the sun, then there would be parts of the Earth that would get more direct sunlight than others, just like if there were no revolutions or no tilt. Okay. And then what would happen if there were revolutions but no tilt? So if the Earth's axis was straight up and down like this, and it's going around the sun, right? It's going around the sun like this. If there was no tilt, then we wouldn't have any seasons because let's think about this. If the sun is here and we've got the Earth, it's angled this way, okay? But then as it revolves around, it's tilted away from the sun. But then it comes back around, it's tilted towards the sun. So different parts of the Earth, based on what time of year it is, are hitting the sun is hitting different parts of the Earth um, more or less depending on what time of year it is. Okay, so unequal heating of the Earth is caused by the tilt and that the Earth revolves around the sun. Both of those two things are very, very important for seasons. Okay, and Earth's axis is tilted. Okay, it's tilted. Okay. Okay, so on your notes, go ahead and fill these notes out. Unequal heating is caused by the blank of the blank and because the Earth blank around the sun. I said that like 4 times. So hopefully you remember. If you don't remember, go back and rewind and look. Earth's blank is blank also said that. So if you don't remember, go back and listen. Blank heating of the Earth causes blank. I also said that. So, go ahead and fill out your notes, color this little globe, and then On your globe, this says 23.5 degrees. That's how much tilted it is. This would be like 0 degrees. 23 is like kind of like that a little bit. So go ahead and draw your line that's like this kind of same angle on this globe and then color it. Right. Okay. Once you've done that, let's move on. Okay. So we have here a picture of a flashlight pointing directly and also kind of indirectly. Okay, the sun gives out the same amount of energy each day. The stuff that the sun puts out is always the same. Depending on, that should be on, not of, depending on if the nearest pole is pointed toward, okay, I didn't proofread this before I put it up here. Okay, it should say, depending on if the nearest pole is pointed toward or away from the sun, can change the angle of the light. So depending on if that axis, right, that pole is, if it's pointed towards the sun or away from the sun, can change the angle of the light. So in the summer, the light is more focused, so we get direct light. So us in the northern hemisphere, where we live, the sun's light, because the earth is tilted towards the sun during the summer, the North Pole is pointed towards the sun, then we get more direct light in the summertime. So in the winter, the light is more spread out, so we get indirect light. So here during the summer, we get direct light, and in the winter, we get indirect light. So this first flashlight represents the summer, where it's more concentrated, so it's going to be hotter. And then this flashlight is like the sun during the winter, where it's kind of pointed at an angle, and so that stream of light kind of is spread out, and so it's not going to be as concentrated and warm the earth as much. Okay, an example of this is in December. Well, we know in December most Decembers, there's lots of snow on the ground. It's really cold, right? And the days are really short. Okay. This is because we get indirect light during the winter. And when we get indirect light during the winter, the southern hemisphere, people like in South America, in parts of Africa, in Australia, that are south of the equator near the South Pole, it's actually really hot there because the earth, the top of the earth, or the north side of the earth, is tilted away from the sun, but the southern part is tilted towards the sun. And so even though this is what Utah looks like in the wintertime, this is what it looks like in Argentina, which there's palm trees, it's hot. They have like their Christmas tree up, and it is like no snow on the ground. It's really hot, really, really hot. My sister-in-law is from Brazil, and she always says that the hardest time to go to Brazil is for Christmas in December, because it is so hot. And it's already hot in Brazil, but it's even hotter than hot in Brazil. Okay, here in summer, the pole is pointed towards the sun. In winter, the pole is pointed away from the sun. So the North Pole during the summer is pointed towards the sun. The North Pole during the winter is pointed away from the sun. So what I would like you to do is color each of these Earths a different color. So you'll have 4 colors. You can choose whatever colors you want, and then match that color in the box that it goes with. And I'm going to give you a little hint. Now, we know the order of the seasons, right? It goes winter, spring, summer, fall. So this one over here, because the North Pole is pointed toward the sun, that would mean it would be summer. So if this one's summer, okay, you have to decide which one is winter, which one's spring, and which one is fall. So go ahead and label that on your paper. Once your paper is all filled out, go ahead and turn it in.